Hi, so in a previous video we tore this to pieces, had a look at the inside, put it back together and used it, and it was pretty awesome actually. But it sparked off quite a bit of interest, and my interest too, in these hahah generators and torches. Now that's a really simple design, it's just a canister, but a lot of people pointed me at something called the dry cell. Now the dry cell reminded me tremendously of a bipolar plate. So I had a look at the price of these things, and these things are expensive, for what they are. But I'm kind of not surprised, because almost universally they use stainless steel. And stainless steel is a nightmare to work with. It's difficult to cut. If you're going to drill it, you have to watch out for your drill bits, and you can just eat the way through the drill bits. If you have them laser cut, actually it ends up costing probably a bit more than if you just went ahead and bought one. And so it seemed to me for a second like a bit of a dead end really, that I'd either spend an awful lot of time and money making one, or I'd buy one to play with it. But then I read a research paper called A Systematic Study on Electrolytic Production of Hydrogen Gas by Using Graphite as an Electrode. I thought, oh, that's interesting. So they did a study where they used stainless steel, mild steel, copper, they tried aluminium but it destroyed it almost immediately, graphite and carbon as the electrodes in a dry cell. And they got the best results with graphite, which I thought was really interesting, because of course people are kind of worried about stainless steel. Most stainless steels contain about 11% chromium, and of course chromium being released into the environment is not a good thing. And they do rot, which is why your electrolyte goes that muddy brown colour. That's the stainless steel rotting away, and all the chromium salts are in there as well. Mild steel obviously doesn't last very long, and copper and aluminium just get eaten away. But graphite apparently did really, really well, and when they looked at the volume rate of production, graphite was the top one. And I thought, wow, that's so cool, because we have a ton of this stuff, which is graphite foil. And I thought, okay, well, if we can use graphite foil, then we're on a real winner. So what I did was I prepared 10 neutral plates out of graphite foil, and they were a piece of cake. I mean, I cut those out with scissors, and then I used these hole punchers here to punch the electrolyte hole and the gas holes. Made 10 of those, probably, I don't know, 20 minutes, something like that. Absolute piece of cake. Made 10 of them. And then I made 2 end plates, which are here, and I buried a bit of copper into the end plate so that I could have a current collector. And then I'm going to do 2 cells in a dry cell configuration. So I made a midpoint plate as well, which I'm looking for. There it is, where the midpoint plate has a electrolyte hole and gas holes. The end plates only have electrolyte hole on one and a gas hole on the other. Then we laid them up in a dry cell configuration. So I cut myself a couple of acrylic plates, put a load of bolts in it. There's a gas out on that side, an electrolyte in on that side waiting to be assembled. I used these things. You just buy these online, they're little gas nipples. This is brilliant. It's a drill and thread. So I drilled and threaded that, screwed that in, bit of super glue. Again, I don't know, 20 minutes or so. So to put this whole thing together, the longest thing was the neoprene gaskets. That took a little while to cut out. The rest was a breeze with scissors and a carpet knife. So I thought, wow, okay. And that was really cheap as well. So I think that given this is, according to the research, is supposed to be the best material, it's also the easiest to work with, which is astounding. So I cut all those bits out. I'm now going to lay them up, so I'll give you a close-up of the layup process. So there's the hole punches that I used. That's the large one, 8mm, and the small one, 4mm, and that's what I used to make these gas holes here and the electrolyte hole at the bottom there. Those are the little gas and water nipples that I used, and that was the drill bit that I used, a tapping drill bit. So obviously I've drilled out the screw holes on the acrylic plate, popped that in. This is the outside, so the gas will go out. So first of all you put a rubber seal on there, and then we take one of our end plates, the actual end plate, and that goes, so let's see if we can get this the right way around, that way. So that goes that way, where the gas out is at the top. It's a bit thick, this one, so it's a little awkward. Then we put another seal on, and then the gas facing to the top with the electrolyte hole there. Another seal, gas facing to the top but the electrolyte hole the other way around, and we keep laying that up like that until we get to the mid plate. When we get to the mid plate, that obviously has a gas and it points the other way on that copper tab. Then we continue with our seal plate until we get to the other end plate, in which case it goes that way around with the copper facing there and obviously the electrolyte inlet the other side, and then that goes on top and gets bolted down. So I'm going to do that and get back to you when that's all arranged neatly. So there it is, all bolted together and complete. Now, what we've got here is effectively two cells back to back. So we've got two here. If I connect both of those to negative and that one to positive, what we effectively get is two cells with 12 volts across each. Now, it doesn't matter, that can be negative and they can be positive, it doesn't matter which way around. In between each of those power plate sets, so between this one and this one, and this one and this one, are 5 neutral plates, creating 6 cells. So each one of those has 2 volts across each cell, with each unit having 12 volts, 2 units at 12 volts. So it's 2 units at 12 volts. And that's what we've created there. Now, all I have to do is fill that with electrolyte and turn it on, and it will generate hydrogen. Okay, this is a real lash up, so please forgive me. I'm just checking if this thing works before doing much more work on it. All I've done is stuck the out pipe into some water so we see some generation. Here's a little cell. Now remember, it's 5 by 5 despite this massive overbuild. There's the hydrogen out. The water in I've actually lashed up to the original machine that we pulled apart yesterday. I've just put it on that. I'm using that as a reserve tank. I've also lashed in the power supply here from this original machine, and I've put it into the power plates of this, and then it's on there. So I'm going to turn that on. There it is, producing hydrogen. That's quite a stream of hydrogen from that little cell, HHO rather. Okay, now I know I've lashed this all together. I mean, really, it needs its own power supply. It could do with its own bubbler. It needs a feed tank. So it needs a fair few things. But what I really wanted to do was demonstrate that that all-carbon cell, and remember it's graphite, really works well. I mean, we had to put an original 15% solution in this thing. This is 4%. That stream of hydrogen that was coming out was pretty significant, I thought. It ran on about 12 amps, previously it ran on 15 amps, so it's telling you really that the conductivity is down by about a third of what it was, and yet the amp draw is round about the same, so it's roughly 3 times more efficient than this thing that we had in here. That's kind of impressive, hey? But like I said, this is pulled from the research. It's not me and my wild fancy ideas. It's pulled from the research of using carbon in this setup. Now, the benefits of it really are, talk about easy to build. I mean, I made this with a carpet knife and scissors. Very easy, no mucking around with stainless steel, which is a nightmare, if I'm brutally honest. Very much cheaper. I mean, these things aren't cheap. They go start around about $100, I think, and just go up just for this bit. So it's very much cheaper to build, very much easier to build, very much more efficient. What more do you want, really? So I'm going to probably build a power supply for it tomorrow. I'll build the other bits from it, and the idea is to get the torch running and replace this entirely with this dry cell. I'm very pleased with how that went, and I'll keep you up to date with the progress on it. I hope it was of interest, and thank you very much for watching.